Great. Should we get started now? Yes. Yeah.
Sure. Yeah, if you want to.
It's I feel like a lot of people have deadlines, either school or paper at the moment, so let's find the time.
Right.
Great. Right. So the plan, well, I kind of said I was going to do this paper, and then I kind of got distracted. So I was like, oh, okay, maybe we'll just do like half of it is related work, and then we'll try and take what we've learned from the related work and apply it to a critique. And then as I was doing related work, I think you might have got the hidden again. We'll see what time we finish. Cool. So I'm going to put the related work on a sort of spectrum. So from one end, we're going to be just get the student to use a real life proof system. So we'll give the student like actual cock or lean or something, and have them play with that. The next level is where we take an existing proof assistant, but then we like add some kind of like translation level or add some UI elements to it. And finally, we just create our own entirely new version of a proof system that has its own features. So let's start with just giving students talk and see what happens. These are some people in Germany that did such a thing, where they took their kind of logic and discrete math course and made sort of half the exercises were on paper and half of them were in code.
Undergrad
Yes.
or
Undergrad? Yes, I believe so.
like early undergrad, late undergrad?
I'm not going to be able to answer this question for every paper in this presentation, but I'm pretty sure these were early undergrad, but they may have taken like a very foundation course before, and then they've got hello. Yes. So this is from their abstract. This is one of the advantages they say of using Coq instead of just pen and paper. In comparison to pen and paper proofs, students are profiting strongly from systems immediate feedback and scaffolding. I think that's a first point of motivation is immediate feedback. Like Coq will tell you if you're wrong a lot faster than pen and paper. Scaffolding is kind of where if you have no idea what to do, it can kind of reduce the space of things to do. Although we'll have a more detailed discussion of scaffolding later. Yes, cool. Another advantage, which I really like the way they describe this in this paper, is an advantage of Coq is that it's so explicit and high level of formalization. And that doesn't immediately sound like an advantage because you would think that the high level formalization makes it harder. These guys were hypothesizing that it's not because it's like that students don't find discrete math because it's so formal, but they find it hard because you have to like pitch your formality, right? Mm-hmm. Like you have to work out what formality is my lecturer expecting and then give that exact formality. And if you're so close to the bottom, why not just make something actually formal?
Oh, so this is like the fact that you actually just say apply a soak or whatever is actually nice rather than how do I justify myself on this proof without hand waving, right. But also not wasting my time.
Exactly, because in any discrete math course, you'll always be asking, "Oh, have I given enough detail in this proof?" Right? Whereas Coq will tell you.
I actually never ask that. I just don't give any detail. I just say it should be obvious to the grader by inspection. Well, Coq will, it's green if you've got enough detail, and it's not green if you don't.
Yes.
Yeah. So this is what this is an interesting point on the. You would assume that Coq is just too difficult for these undergrad students to understand, and well, there was another paper that said that there's a problem with like the overhead of learning Emacs or like the overhead of using Coq IDE, which is apparently quite buggy or something. Yeah. Like there's those trivial things, but actually when it comes to using the actual interesting features of Coq, students required surprisingly little training to get used to work with the theorem prover. So it turns out that the usability issue is not as big as we thought, or like students can get used to Coq a lot easier than we thought. The other thing we can see that the scaffolding kind of work in that compared to the pen and paper proofs where students were like finding it hard to work out where to start. Coq proofs there had more satisfaction, low attrition rate, and overall positive feedback in the surveys regarding the interaction with Coq. This kind of has a sort of darker side to it though, because it means that while these students are very happy to use Coq, they're still struggling with the pen and paper proofs. So they've in fact they're enjoying Coq, right? They're positive feedback, motivated to work in studying, and then you give them pen and paper and they don't know don't know what they're doing. There's the you could ask the question, oh, are they just randomly getting it right? Like, are they just trying out tactics and seeing if they're right? The GSIs claim that no, it looked like they were really understanding it. So I don't know how you test that formally, but you have their word there. Yeah.
I wonder if there's in analysis, like you have like, Python programs and like the direct auto graders sort of thing. Like versus like telling them on an exam to handwrite Python or something like that, right?
Yeah.
I don't know.
Yeah. Because in that case, you do have the feedback. Yeah. Yeah. So here's what they decided what the problem was. We rather believe that within our course design, we did not pay enough attention to how Coq as a scaffolding element is dismantled carefully. So this is an important point, which I'm taking a Cognate course in education, and these are two of the slides from that Cognate course, where they're making a key distinction between a scaffolding and a support. So scaffolding is something that you'll get rid of once the building is finished. So in learning, you want to have something that helps you when you're starting off, but that slowly fades away from you. And support is something which you can have the whole time. So like I imagine calculators in math as something of the support, right? Like the sine button helped me to calculate the sine of an angle, but I'm not able to calculate the sine of an angle without the sine button. Whereas the scaffolding is something where you can learn with it, but then take it away. And so it appeared that even though Coq is surprisingly easy to use, it doesn't work as a scaffolding. And I wonder whether that might be part of why it was surprising that it was easy to use, is because we were imagining like that the students would be trying to correspond Coq proof to written proof, which is hard. But actually, like if they're just doing Coq proof and that's all they're doing, then they're not doing the corresponding, then that might make that easier. So anyway, we've got a whole cohort of people in Germany now who absolutely love Coq and just cannot write anything on paper. So what are we going to do with these people? Let's see if we can. This is a follow-up paper by some more people at the same university who are trying to get this cohort to be able to write normal proofs after they got.
How far? Like how many years after this one?
Oh, I don't know how many years after this was.
But it was a study over the same cohort.
I don't. This cohort certainly had the same course as the previous paper. I don't know whether it's the first cohort or a later cohort. But they say they're developing this alternative approach to teach computer scientists how to prove. First, they're taught how to prove theorems with Coq. In a second, more difficult step, students will transfer their acquired skills to the area of textbook proofs. So it's kind of surprising how intuitive. Like these guys are finding it like really easy to teach these guys Coq, and then really hard to move it away. So yeah, this is their kind of like, here's our goal. We have step 1, master Coq proofs. Step 2. So this is what they came up with. The first step is you take the Coq proof and you write huge comments in, basically. Like explain everything that happens in between each step. And then you turn that into a sort of structured version of that. And then you turn that into a written proof. So they've tried to make this sequence of steps that you can take. In the end, I don't know, they said there are some successes, but this paragraph kind of led me to think that it's not going that great, because the average students estimated their skills to be between medium and weak with understanding of the proofs, but then the usability of cock is still good.
Sort of wondering, like, I mean, for that last example, that was sort of like a direct translation of the proof. And that sort of proof on that side is sort of forced upon you by maybe the structure of the rules that you have to talk, or maybe not in that particular case, but I could see that being like there's maybe a method, a formalization method that might be different than the more relaxed paper and pen proof. Something
Yeah.
like that.
There is something in well, I mean, one issue is that, cock is just word full stop, word full stop, word full stop.
Right.
Whereas on the right, you have to add some like indentation, like you always have to add structure.
Yeah, I see. Like even just the indentation stuff.
It's interesting. Yeah. So I guess the interesting takeaway here is that the reason you would not use cock is not because cock isn't usable, but it's because you want something which is a scaffold. I think scaffolding turns out to be like the most important question in if you're looking at using a proof system in education, like can it fade away?
Sure, right.
Unless you just want students that can use cock and can't prove,
Right.
which
Well, I don't know. It seems like the point of the course would be like to learn underlying mathematics, and this would hopefully be a tool for them initially to do that, right?
did you something else?
Did the students the ones who wrote those comments in the clock tactics, or was that given?
The student this was an example given to them, but they were asked to write this out. Yeah.
Well, their feedback on this that was autograded.
There was oh, I don't think it was auto graded. I think it was graded. And they also the students did rate this as a kind of slightly what's the word? Like annoyingly repetitive task as well.
Yeah.
Yeah, I think there's better approaches than this kind of
It makes me wonder if tactics-based approaches are not like you're writing the things that would be in the sidebar.
yeah.
Going back to sort of like an Isabel style high level proof versus the Cox style applies.
Yeah, Isabel style or like explicit proof terms.
Yeah.
Would probably be much easier to translate into like being able to say like we do this by case analysis. It's literally a case analysis in AGDA is a lot easier than noticing that like at some point in the sequence of tactics and split your goal into two goals.
Right, when it's just a bullet point or something like that, a destruct and then implicit bullet points.
Yeah.
Well, let's take a look at the next system, which I think has some of those ideas in it. So we're now going to look at one that provides an interface for cock. So this is waterproof.
Water.
I find in the research for this presentation, I found all these things I'd never heard of. It's like very cool. We keep going. Anyway, waterproof is for the sort of literate environment, so you can have sort of paragraphs and then have definitions inside. That's been a useful education feature. You're going to notice they've replaced all of the cock tactics with things that look more English. So like it's running cock code. They've defined these in the same language, right? But the grammar is just stuff that looks more English.
Yeah.
It's like syntax extension support for that.
I think so. Yeah.
Interesting.
And so these are the tactics that they have.
Oh, sure.
Help. We can clear that. Assume that.
Nice.
And like what you were saying with the cases, they say that like in a normal proof system, you would have the structure, you'd have something like the top.
Yeah.
Whereas here, what they've done is they've made the either tactic have 2 extra requirements that can only be satisfied by commenting case. Like the case expression solves a sub goal, which is just using in order to make sure that you've written out.
That's funny. Yeah.
What the case is.
Yeah.
The back and queue and when you've written just the dash and there's sort of like the feedback to the user at that point, and something the need for the case.
Oh yeah, I don't know whether they hide that in the pre-progress or not.
Yeah.
Yeah.
Or I mean, what things can you sort of click on them where your cursor is and it sort of like unpacks that instantly? Or do you know what that the nature of this like common tactics interface what it is?
I don't know.
Yeah.
I don't know if it's like sort of like a Lego brick that you like click in and they're like, okay, do that back. Got it.
We can give it a try.
Wow, wow.
Okay.
So you have the common tactics thing on the side,
Yeah.
and then
What do you just like?
I don't know, oh, you just copy it, does that, and then paste it in.
Yeah,
Yeah, there we go.
that we could actually, it's a tool.
Nice.
Yeah, this one actually it feels like it's been used quite a lot. Like they've got there's other papers that build on it. Like there's a paper that says this is how we do linear algebra in this system.
Well, your thing is, I guess you have to, if I wanted to say we conclude that, you'd have to go to this copy thing and you just like drop it over there or something.
Yeah, I guess so.
You type it, or you have to copy it.
I guess you have to go. Oh, what is this? Oh, there we go. That adds it.
Okay,
That current location.
Yeah.
So it's kind of like from scratch, like it's like you have to select from the sidebar.
Well, you can type as well.
Okay.
That's unfair. I couldn't get the buttons to work. That was unfortunate. Again, I couldn't get this to work. There's a tutorial page which says if you press Alt and down, then something will happen. And I'm pressing Alt and down, and nothing will happen.
Interesting. I think it needs to, it's loading on the right. I think it probably needs to connect to some running pocket since I guess.
Okay, yeah. Right.
Interesting. Okay. Anyway,
Yeah, cool.
yeah. The other interesting thing was that in the paper, I keep clicking on Zoom and it takes me to the other desktop. They didn't make their students use it. They just present it as an option. It's like, hey, you're gonna have to produce these long proofs. If you want, you can do it in waterproof. It says 16 groups handed in homework in waterproof at the start of the course, and 9 were still using it by the end of the course. Whatever that is. They also didn't say how many groups there were in total. Which feels like important information. Yeah. Or at least I couldn't find it.
From the start, it was optional, or did they force you to do it for one assignment? And make it.
I think it was optional from the start. But then they said they didn't give any instruction on how to. You wanted to.
The groups are 6 size of the right? Yeah. More than 16.
Yeah, I guess so.
What for 60 gets Florida 36. Yeah.
Yeah.
Well, they can always good fun of lunch.
They get product when,
I don't think they did.
why not? That would be
Yeah.
higher,
Yeah. Seems down from Ben's point. There's an interesting piece of feedback in the paper was that one student stated that the program often acts as probabilistic as to whether or not it will accept a step in a proof. For example, a plus 1 equals 1 plus a will be accepted, but a plus 2 minus 1, whatever. Which is another interesting thing in like tactic languages. The
I like that.
the author, the author of the paper contend that waterproof can actually verify that second one. But yeah, there's a general problem with tactic languages is that it's hard to create a model of the computer. And like if it's hard to create a model of what the computer's doing when it's helping you scaffold, then that's kind of a good sign that the scaffolding can be hard to take down. Yeah. So here's another system which goes over cock, which is like I thought it was just a simple propositional logic thing, but it's like blown me away. So it's been used by a lot of universities. You can also see they're in one particular country that really likes its formal methods. But
Yeah.
it's a lot of pieces, and then they have these like videos showing a little demo of. So this is
Good Germany.
This is the proof that the sum of the natural numbers up to a certain number is n plus 1 over 2. And so you see they're clicking on all these buttons.
So you're using this? Like,
Yes.
Student units? Not the
Oh, this is the developers just showing it. It's going way too quick to be a student. Yeah. Like, I can barely take in what it's doing.
Yeah.
You see, it's a cool, it's like a structure editor proof thing.
Yeah.
You can click on, my guess is justify as things that you, trying to prove, and deduce as if you want to take a assumption and work from that. You've got all these kind of options for deduction.
This is saying the sum of the first n integers. So the proof is 1. E is true at rank 0.
Yeah, so that's induction.
So where do you actually say you're doing this proof by induction?
So what they did was that in the justify button, they've got the word by induction.
Okay.
And I don't know where they state that they're doing it by induction over n.
Right.
Like it seems to have magicked that.
Does this
You see they've
backend
chosen
get verified by copy, or is this sort
Yeah, supposedly it's all cock in the back end. Yeah.
of
Which is surprised, like,
yeah.
maybe these are just cock tactics or something. But
Right.
yeah. Still, that's a very powerful back end for a point and click thing.
Yeah.
Yeah.
Nice. It's open source.
No, it's a company. And I think they have a paid model as well. So
You said you want to tweak it. You can't.
I suspect not. But I don't know. We can
Yeah, right. It's how this works.
Yeah.
yeah. They've got all sorts
So
of
make some obvious improvements to the UI though.
yeah. Yeah. There's here's another cool demo where they're doing a proof on a vector thing, and they've got this little picture. Like it highlights what you're highlighting over. So like, yeah. But again, it's going too fast. But like, if they highlight over, assume J is the midpoint, so AC, then you end up with highlighting over that line.
Nice.
Vector proof.
Nice.
Anyway, yes.
I took this seminar in grad school from a Turing Award winner. He pulled up one of these videos of like a tool being used and like slowly forgot it was a video and started to try to interact with it. Turing Award winner.
Yeah.
Well, it's also nice. We'll see later that user studies are few and far between in this field. Like, very few actually check what students are taking in. But this is a lovely user study on education, if a little bit French. But yeah, which might be why it's somewhat undercited in the field as well. Like I feel like Educura has a lot of potential. Is very cool, and it has a lot of utilization.
Cock and lead and something else. Cock, deduction, educara, and lead. Comparing those four tools.
Yeah, I mean,
The top, right?
where?
Says did a demonstration using some of the assistant thing.
Right. Yeah.
Deduction, educara, and lead.
Yeah, so they're describing 5 things. Yeah.
Are they like comparing this directly to lead and deduction, which I think is also a lead thing and
Yeah, I mean, maybe I should double check the paper. To me, it felt like most of
it's
the.
in ChatGPT, it'll translate.
I'm sure it will. I'm sure. It will. Yeah. But the data that I saw was all on Educare. I don't know whether they actually.
They actually did some user studies and stuff like that then, or
Yeah, they've got some lovely. So this is Yeah, this is a nice thing about coupling is that they were seeing with pencil and paper, students give up Whereas, yeah, that if you have buttons you can click on, then you might actually end up searching for proofs. Here's some slightly less encouraging. This third one is the one that worries me the most. Is I have completed several exercises without understanding anything by clicking randomly, and almost half of the respondents agreed they'd done several exercises randomly clicking.
The third admitted to cheating,
Wait, what?
or more than half admitted, disagree.
I look at the fourth one
Yeah.
too.
No, it's 20 of them, 20% admitted to cheating.
Yeah,
20%. Half of them said they didn't believe it. What's that?
I didn't understand that one. I think it's something to do with like developing a reflex for proofs, but I'm not really sure.
Interesting.
Require automation, right?
They have the sample size.
Yeah, it was something like 200. So
Okay.
it's, yeah, this user study is like, I don't know,
Yeah.
it's pretty big. So this was one unit. This was the University of Strasbourg. There's also another one here where they
That's still in France, right?
yes,
Sounds like a jerk. I think that's all the jerk.
I feel like it's been in Germany in the past, but it's now yeah. This is another another university where they which I guess you can see a little bit of like the top two are like how comfortable are you with the tool, and then like the bottom ones are how much did it help you understand math, and you can see that like people are more comfortable with Ejikera than they are with the understanding of the math, but it's less. I guess it's not that extreme, but it speaks to
Were there exams
issue.
they ask people to do fully on paper proofs at some point?
I can't remember.
That'd be interesting to figure out.
Yeah. You can check the French later. But yeah, so that comes back to the scaffolding question of like,
Right.
has it scaffolded? Has it helped you understand math? Well, it seems like, for half of them, like the green ones say yes. 60% of them, it feels like it's helped them. But it still feels quite a lot for like 40% of them to be like, yeah, I don't think it really helped me understand math. I would have expected more. But
Does scaffolding mean that like the proof assistant expose as little semantics of its own as possible so that like you don't need to like actually know about the or memorize how to use the proof assistant later on to understand what they actually mean in as like the semantics.
so scaffolding, like in general, is if you have a very complex task that you're teaching the students how to do, you find a way to like break it up. So you could say, oh, the students can do this part of the task and this part of the task and this part of the task and this stuff, right? And then eventually you hope that when they come to do the task for themselves, they can remember this was the order that they tried to do it.
Yeah, it's like limiting the search tree of the like proof.
Yeah.
However, like if without the tool and the students still understand what kind of actions that they
Right, and I think that's where it becomes a kind of support. It's that like there's this, if you can't work out what the tactics would do, or if you can't work out which tactics are available in a certain point without the tool, then that becomes good. But that means that you can't then transfer to pencil and paper.
Right.
Cool. This is another interesting point, is that the assistant, so this was, I guess they're talking about all of them here, like lean deduction. Deduction has a really like terrible interface. I'm surprised it gets cited so much. It's got like just like .NET buttons. But anyway, yeah, all of these, there's an interesting point is that all of these assistants use type theory, right?
Yeah.
Whereas normally we teach discrete math using set theory. And so there's an interesting question of like, does this mismatch cause a problem? Should we make the mismatch transparent? Should we make should we try and hide it? Should we just teach type theory, not set theory? Why are we teaching set theory?
Set theory.
Yeah. Yeah. Okay, let's move on to the bespoke tools. This is a paper, I mean, I'm just saying it because of the name, right? They've called it yet another process assistant and automated pedagogical, as if there's been already too many.
Right, yeah.
Does anyone want to guess when this paper was published?
05 for no reason.
1995.
Oh.
Yes, they were already fed up with how many of these things had been published.
We got a hard part, right?
They'd already been fed up with how many of these things had been published in 1995.
Yeah, really.
But the issue is none of them have any user setting, right? There's just someone has, I mean, look, they worked out how to use the graphical interface. There we go. I don't even understand how the deduction works here. Does anyone know the what was it called? The KE calculus. But they've managed to draw a tree, and I feel like for the longest time people were just working out, oh, is it possible to make an interface that does proofs? And so you ended up with people like, they'd just be like, yes, it is possible. You've managed to derive this theorem in this visual user interface. Whereas now, I guess, it's kind of, oh yeah, no, it's pretty obvious. We know that we can do it. It's just like, how do we do it so that students understand, and should we be doing it? Here's another screenshot. Here's another system which has sort of natural deduction.
This almost looks like Pearson's existential, perhaps. Like implication is like and it's like graphic logics, but yeah.
Right, yeah. We've had French. Let's have some German. This is a tool that the input is a subset of the German language. So, Yishan, you lived in Germany for a bit, right? Is this a good proof? No, the answer is yes, because the tool says the device is correct. So what you can write out a sort of proof line by line, and it will translate it into logic, feed it into a SMT solver or something, whatever, and then say whether the proof was correct or not. They've got some examples they translated in the paper very helpfully. So you just literally write, let n be a natural number. Suppose that n is even, and n plus 1 is even. Suppose that n. And somehow that all gets merged inside. What's nice is that this is like, this is exactly
Yeah, it's
what
what
you'd
you
be
want
writing.
to see on an exam, right?
Yeah. Yeah.
How tolerant is it of alternative ways of writing the same thing?
Yeah.
But that was one thing. I think they said that it was like, yeah, it's not that quick. They did say that sometimes it accepts like more steps than you can do more steps in one go than you would want to be able to do. Was also another cool feature is that they have I suppose it kind of that this is like common mistakes. So they've got this SAT solver which uses all the like correct rules, and then they try running it on a SAT solver that's been told that you can use an implication the wrong way around, or that uses all these kind of like common logical fallacies. And if one of the solvers with a common logical fallacy can understand your proof, then you say, oh, you've made this mistake, and so it will try and tell you that you've conflated your calculus.
Interesting.
Somehow it does that without just proving absurdity.
Yeah, but this is somehow they've managed to make it limit to like it follows step by step rather than just proving everything.
That's a good idea.
Yeah.
It's a bit like in a nice pitfall catcher, like in Isabel, you have like a version of auto quick check, which sees if your lemma is an improvable, just runs it and say, oh, I found a counterexample, blank and try.
Oh, yeah. Yeah, counterexample is another good way to do it. I don't know whether they did that. Yeah. Okay. This is a the issue of making your proofs too precise. So I should say that the evaluation for this, obviously they didn't run a user study because none of these people run user studies. And they got a math textbook out and tried to work out if they could rewrite the proofs. So they took an English math textbook and translated it into German onto this. So I guess they didn't quite do it, like they couldn't quite copy it word for word. But, yeah, and they found that they could write out most of the proofs. But this was one thing that they found was that sometimes this system required more steps than the proof did. For example, you've got to show that two lines are distinct when this was obvious because you look at the picture and they're obviously different lines. But this kind of it's a good way of phrasing the putting a finger on the problem here, which is the sociological problem of math courses, where as the content of a lecture develops, certain kinds of sloppiness in proofs become acceptable as convenience in expressing ideas is traded for precision and strengths. So this is an interesting problem. But how do you deal with the fact that things become that's not your hand up. No, okay. Yes, okay, great.
I was gonna ask about that because do you have any idea generally what people's opinions are on this matter? Because like, for example, one of the canonical example I think for this sort of thing is like in readability theory, right? Historically it starts off like so formalized period theory that no one wants to do anything with it. And then like later found out that like it was all just so rigorous that that you didn't really need to be that formal, and then you have sort of more intuitive during readability theory. And people are fine with the sloppiness because they all know that like if you really wanted to formalize, you could, and it's okay. So like so what are you sort of know generally like how people feel about this difference in practice versus formalized proofs that like people are expecting some degree of just like, yeah, I believe you could do that. And so we don't even feel like talking about this splendor detail.
Yeah, I mean, that's a good question. It seems most of the authors on these papers are more in the kind of like fields where you can write out everything, I think. But
it's like, I don't know if you really have like the luxury of doing it. So like import a library that someone else has done, or you just assume actually.
I mean, that would be the ideal situation is you could just import like in algorithms, right? You start off by teaching people how to merge sort, whatever, but by the end you're hoping that they can just use a sort function.
Sure.
And so it would be nice if libraries could work like that. I guess
But even
maybe there's reasons why they can't because you just got to track too much or something.
and even in that case, like your library, where you use mathematical definitions, one's nice for computing, one's nice for proofreading. In your case, otherwise, yeah.
Right, yes. Yes. I mean, what they decided was that it is unclear. Whether DePrush should even try to reflect this part of mathematical practice is unclear to us. Here's another interface which I guess kind of kind of matched perhaps what we're thinking of doing with Hazel a little bit is that they have this kind of like programming centered thing. So they have you define data types, define some lemmas, define some assumptions you can use. So it's not quite defining a program, but it's kind of close. And then they have but it's not the most visually stunning user interface, but I do really appreciate that they've just put buttons everywhere. It's very obvious what you can click up, which is a surprisingly hard thing to have in some of these proof system things. But yeah, they have this induction box like I don't know what happens if you try and add a case now, because obviously this is a Lisp, so there should always be two cases. But
Seems like this one could at least be farmed out, like SMT, like a theory for interpreting functions and data types sort of thing, as it's back like on top of that.
Yeah. These should all be very simple steps, so very easy to do.
Found the induction principle is correct.
So my guess is that is because you can see they've got this add case button. So I'm guessing that they're actually getting the students to write out each case instead of just generating the cases.
Yeah, that's interesting. Yeah, sort of scaffolding
Like it forces you to actually know you're done with the two cases instead of just telling you you're done with two cases.
It's like with the order proof that made you write out the cop tactic that said case. Yeah, case. That's
So that gives you a proof obligation. It's like you have to have these two steps and it would do if you tried to add a third one, it'd be probably nothing very interesting, right? It would give you some weird error message.
Oh, oh yeah, I don't know what happens if you try to have it.
But it still labels a base case an inductive step, or is that something that used that a user talk?
Oh, I don't know.
Add comment down there.
So it's me.
The bottom of it,
What's this about? Well, I wonder whether. Yeah, I don't know where the comments go. My guess is it knows it's a base case. Whether it knows it's a base case because it hasn't got any assumptions, or whether it's like doing it based on the type of, I'm not sure.
Using a move by induction on this definition of data structure list instead of like on L.
Yeah, right. I mean, I don't know if it's yeah. We'll see. Holbert does something similar to that as well. Yeah. Here's a
This would be a good one to like try to get to work, which is running on, but
yeah, I don't know. It's also I think it's a PhD thesis, so it's got like a lot of content.
cool.
Yeah. Here's a fun looking one. The incredible proof machine. There's a drag and drop thing.
I don't know what this is referencing the name. There was a game when I was young called The Incredible Machine, which was like you got this toolbox of physical things, and you had to like get a bowling ball to end up in a basketball hoop or something way over here.
Oh,
you had like a rock
yeah,
that you
yeah.
could attach, and then it would bounce.
Yes.
Uh,
With like dynamite too.
yeah,
and
with
like,
dynamite.
Yeah.
Yeah,
Mm.
there'd be a catch or something. Yeah, it's it was amazing. Yeah, it was a very fun game. Yeah.
Well, as I said, it is trying to make formal logic fun. And here's an example. So we're going to try and prove that A implies C using A implies B and B implies C. So we've got this block here where we can build an implication. So let's plug that in there. And you see it works out that it's A implies C. And then we want to use, so here we have A. And then we're trying to get a C, right? So that's how the kind of like natural deduction bit works.
Yeah.
So we can use these kind of made as Pennon's blocks.
Oh, I see. You're giving that.
Yeah, we give an A, and then we've made a B there, right? So we put the B into the B implies C. It's becoming point. All right. And that's spit out the C.
Yeah.
Yeah. Oh yeah, green. There we go.
Yes.
It's kind of fun. I'm not entirely convinced by this way of representing
Yeah.
proofs. Here's an example where we're trying to prove A implies B implies B implies A,
Yeah.
which is not a tautology, so we shouldn't go prove it. And we can't prove it. But there's the sort of question. So we can build this and here, right? Build the and. And the question is why, we want an A, we want a B here, right? And we have a B here. Why can't we just, can we do that? Oh no, it's red. It's just red.
Interesting. Yeah. They should.
Yeah.
Feel that be within that to go on the path and like put the output of that block.
Yeah, I
I
guess.
feel like you're assuming in some hypothesis and just all of a sudden. It's different.
Well, I guess if we remove this, then can we attach this one in there? Aha, there we go. Yeah, because this
Yeah.
block isn't being used for anything. And this is an X now. He has no idea what this is. That's an X implied B.
Oh,
So you can do that,
okay,
'cause it's just moved.
It's like a sub there.
Yeah, now double back to the That one's from Fielder.
Can you move it to A implies B? No, there we go, it's red. Now,
Their error message when you red line. Or is it
it's
just,
just a red line.
yeah, hover over that X, what is it?
Remove.
Yeah, there's some like logic of things can't be some derivations into.
Yeah.
Yeah, I mean, it's clearly worked out, but it's, I guess, a downside of this choice of representation is that it doesn't show you where you can use your assumptions unless you actually try it. Which maybe that's maybe that makes it a scaffolding feature because it's just telling you which one. There.
What do you say? I don't want.
Yes. Great. Let's look at the paper that I said we were going to look at with 5 minutes to the end. So this is another example of a interface with some proof stuff. They've written the paper in Hilbert, and it has some things which nicer than PDFs. Like you can hover over the citations.
Oh, wait, so,
If only you could do that in normal papers.
yeah, this is like, if. Oh, I see. Okay.
This is in Hilbert, right? They've got like actual proofs later down and stuff that you can like manipulate and stuff. Let's destroy that so we can work it out later. But yeah. No, so it's yeah. What's interesting at the start, they've got early results from evaluation studies show that students profit strongly from persistence. Which, yes, I mean the thing is they've cited that group of Germans that don't know how to prove by paper. But
It was.
it did show that they did enjoy using talks, that it did help. But yeah, it's a little bit. Shows you that paper citations don't always give you the context. Yes. Yes, let's take the tour. So they have like you can add a box that has like axioms in it. Oh. And so they've got all of these normal natural deduction axioms. So I guess they're really teaching like very formal logic. This is like a discrete math course. This is like a logic course. We've got here's some introduction and elimination rules for all of those things.
You can edit the those stuff in manually and such, or.
Yeah. I mean, the text editor is not quite as.
Sure.
It's also that's prefix notation as well in the text editor. We can mess about. I see. It's there we go. Change your axioms. I don't know if it's still sound enough. Yeah, I don't think that sounded at all. But there we go. Yes. Where did they say? Right. Of course, this does not mean that Hilbert is technically. This does mean that Hilbert is technically unsound, right? Because they've decided to make it an untyped variant of the Lyman calculus. There's no requirement that the Hilbert theorems be trustworthy. To paraphrase the Foxer phrase, "Doctor, I can prove bottom when I do this." Then don't do that. So yeah, don't do that. But we now have that available to use later.
So you can, if that that deduction that you didn't delete it. Back and like find this rule here.
Yeah. I don't know whether it's actually useful for this one.
Sure.
But we're trying to prove that A and B implies.
You use that with NDP, you say.
Right. Yes, let's find that then. So it was a non-introduction rule, right? Which rule did we destroy?
Top one.
Oh, yeah.
This one.
Yeah.
Great.
Plug it in.
Plug it in, and then what do we need?
Like, what is it?
What does it do?
We've got some unresolved meta variables.
Return.
Oh, right. So we just need to put true in there, right?
Yeah, you used to.
Nice.
So if you want to prove it.
Oh, wait, if we put this to be true,
Yeah, take that.
is it slash top? No, it's not slash top. It's true. Oh, we instantiated it now. There's no going back. Let's actually prove it. So they've got the elimination rules that they share in the available rules thing, which turns out to be most of what you need. So
Intro.
oh, sorry, intro. Yeah, intro rules. Yes. So we've got
So when you get to this situation, there's like it's like filtering out. Like you could try to prove this with an linear rule on hand, but it's like not.
yeah. Right. Well, what was the? I try and you out. Yeah, if we can show the non-introduction.
You messed up.
No, that was the other one.
Okay.
That was
That,
fine.
Yeah.
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 Or no, you could, yeah, you
Yeah,
could.
we could prove that.
you could prove
Yeah.
that. What you can do is if you go back, you can go from the elims down to, you can do down like backwards or forwards.
Well, so it's when we get to B, we've got the choice of doing backwards or forward reasoning, right? Because if we want to prove B, we need to get it out of the A and B, right? So we could either go on here and do the do the rule that we messed up. Or we could start with this one and then it will give us the one straight. Yeah. Anything here? I guess we messed that rule up, so that will. Yeah.
Needs and elimination left anyway.
Yeah, let's skip over higher order abstracts and things. They've got this cool inductive definitions thing. So if you want, yes, this is an interesting point, is that it's untyped. So this is the thing being an actual number is a proposition. So it's like what we were saying with we said it was weird that they called it induction on the definition of data structure list, right? Well, here, like all you can do is define this is what it means to be an actual number. So you have to just do an induction. And what's cool is that they take whatever rules you produce and derive an induction. So we could add another successor. How do you? Never mind. I didn't. I can't remember how you add the kind of inference rule that you particularly. Yeah. Yeah. What's also another cool thing is that they have the kind of written out proof. So you can if you haven't the tree, let's get the tree we proved most of before. There's a little button at the top that says we can turn it into a prose proof. And then it is using the kind of words that you would use.
Oh.
Yeah. I don't know, is that scaffolding? Would that fade away? I don't know. Because some of the aspects of like the way this stuff works up here feels a bit like in some sense it's just finding the applicable rules. So that might turn out to be hard to transfer. I think they've tried it on students, but they haven't written that up at all. So
Yeah, I thought about putting this into my course. But when you do the questions on the assignment that I know students have trouble with, you could just click.
right.
Almost sort of use them anything. Get the questions on the exam on.
Right. Yeah. I mean, one question is like, can you prevent the click by making them prove much more complicated things? Like if they can, but then I don't know whether your tool has helped them so much that they will be able to do the more complicated things, or whether if you try and give them more complicated things, then
Well, I think for propositional logic, I think this will always find proof.
Oh, right.
Sure.
Yes, yes.
Proof search and logic.
Yeah, I wonder what, like, if you give them sort of an exercise where you have to have them sort of derive their own set of rules for some particular problem that they work on. That seems, at that point, that might be preconditioned on knowing how to work in one of these.
Yeah.
Yeah,
Or perhaps you should make the proof system less automatic when you are doing application purposes.
Yeah, right.
if you get rid of this thing where you can click on assumptions, then you just
Yeah.
force them to apply the bottom-up elimination or what they, that. Forces them to do backwards reasoning from their assumptions.
Right, right.
I think that would solve that particular problem.
Mhm.
It's like the hard, like students are pretty good at applying the intro rule. If it's applicable.
Right,
I
right.
actually didn't say that, but it's so easier. But the limb rule is like you have to kind of work backwards from you want to get to C, and so you have to notice, oh, there's an application to C, and that's starting to B, then I'm sure. It could be, right?
That's the inside part.
What's that?
That's the inside part of the.
Yeah. And that's the only place where you need any insight at first order for, right?
Students are good at
Oh, and-
using inductions recursively. Like I want to prove something on natural numbers. I start at 0, I do induction, and now I have 1, I do induction, and now I have 2.
Really? Which students do this?
Oh, yeah, no, so if you talk to students about induction, they're like, yeah, I get how this works. Start at 0, then do 1, do 2, and get to N. And it's like, that's kind of what's happening, yeah. Well, like in their mind, it's like an et cetera, right? It's like dot, 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 and instead of like, yeah. The sort of
Construction thing.
construction by assumption.
Yeah.
Same with recursion. It's like correct all of recursions because they simulate the whole stack being built up, and then they're trying to like work with the stack and simulating the stack getting popped. And you're like, no, just pretend the recursive call works. Don't go down into it. It works. It's like, oh, I don't want it that.
Did homework get any listening classes or
Yeah, so I think it has, well,
their whole?
I think in some email correspondence, someone told me that it had been used, but I don't think he's, oh, no, he said at the bottom, he said it's been used in. But then, like, I looked up these courses and couldn't find them, but it has been used in classes on logic in TU Dresden and wherever that is. Yes.
It's this.
Oh.
Formalized martial law light theory in Harvard. What?
Just.
Yeah.
Oh, okay.
That is.
Interesting.
I mean, what's nice is that because they have the like, the infix notation and it's completely untyped, like it ends up being basically the same calculus that you use on pen and paper inferentials. So
That's fascinating.
yeah.
So could I have a new derivation using Martin law type theory in Holberg? That would be more interesting. There's a lot of it.
Yeah.
So they're using defining structure from the underlying untyped calculus here. That's right. How are we doing?
I was about to say, wait, isn't it a simply type thing, but right now it's.
Holbert is not typed, untyped.
Yeah, it's untyped, but it has binding. You see there's the little X dots next to the
Yeah.
Yeah, right.
saying like X is bound here because there's a leave it there. And it's somehow
Yeah.
like internalizing that into the element, I guess.
Yes, I think it's that. Yeah, there's one slightly unintuitive thing is that there's a bunch of these X's kind of just appear and disappear.
Yeah.
And like in a proof, well, if there's a proof or something.
But some of like higher order abstract syntax that going on here, but
you'll notice the left-hand side of this pen style kind of disappears higher up as well. Like they've
That's 'cause you
confusingly
have,
just got it.
It's an option on the right.
Oh,
View context all.
oh, new only. Oh, okay,
Okay.
okay. Oh, yeah.
What are some of the Lego groups that we can play? See how busy. Okay. I mean, I guess you have like the options there, so like,
These zeros and ones are kind of annoying, huh?
Right.
Wait, what's that gonna fight? Oh my god. That, the one that's like cut off at the top of the screen, right?
It's proof.
There's like an impalement inside the impalement. Where?
Oh.
Oh. Yeah.
They're all like stacking up.
Is it? Like, let's do this. Maybe not. I mean, yeah,
Lambda x dot b x that's like the arrow. Like you can add arbitrary judgments to your. Function. Yeah.
I mean, the
Oh, that element you call it x dot b x. Like, but
yeah. And they've just used this symbol as well, maybe inside. They've defined their own. No? Maybe not.
yeah, this probably has something to do with my confusion about how they combine the system.
Yeah, I mean, they do explain it in the paper. But I, yeah, didn't really have time to get chunk it out as the.
It's just, it's not quite slick enough that I give it to students, so I think you create all this extra. Side balance. Yeah.
Right, right. Yeah.
The logic,
This one is open source. So.
yeah, well.
And mess around with that.
It's pretty close.
Yeah.
For general data, maybe for teaching. Breaking type theory.
Yeah, right. You're very specifically manipulating rules, so that's yeah, okay. That's all I had to say.
What's that? Oh. I guess from diving into this, what would you say like the state of the practices for having? I guess like, yeah, user studies for this and educational studies for this. It seemed like there were some of those papers that had this components to them. But some like this one don't seem to mention it at all.
Most of them don't. Yeah.
Yeah.
There was just the Cock one at the start had a sort of they got the GSIs to keep track of what questions people were asking when
Right.
were then able to piece together what was difficult. And then there was that French review.
Yeah. Is there any barriers to it? I mean, like, do you really need any other like conditions on funding under a grant to be able to do something like this? Or I mean, is there besides just having to know how to run these studies? Like, I don't see a reason for not doing them.
There's. Running a user study on any sort of system that has like a lot of different design decisions in it is really hard because what are you even evaluating?
Hmm.
You're not going to evaluate each UI choice or something, right?
Sure.
So then it's a question of like the overall. So you have people that do things like we thought with the data earlier in Matt's talk, right? Where you're like, did you enjoy using this or whatever? And
I mean, what,
There were user studies, that was the extent of it, right? You can't.
yeah.
But
I mean,
I mean, it would be nice if more of these papers had, did you enjoy using this?
well,
Yeah.
even and just beyond those questions too, I mean, were those questions sort of influenced by any sort of like CS education research or anyone with that sort of background? Or was it just sort of, I'm gonna pull these out of the hat and ask students sort of questions?
I don't think it's influenced very much by that. You need to, yeah, CS education research would identify learning goals.
Yeah,
But even then, it's hard to. You need some sort of control group for something, and you can't do that in a single classroom semester, right?
yeah,
You gotta do it between semesters, that's stability there. It's like I lecture slightly differently each semester, like there, any changes that you observe, you can't necessarily put on the tool being different, because there's. Your TAs are different, your lecture's different, maybe you cover different topics, maybe you break and ended up in a different spot.
yeah.
Like.
Yeah.
It's a hard thing to do user studies and education in general, and especially for such a like. Complex. Intervention. I think we could do better than we do. Like, I think the papers that just do nothing and just like describe
Yeah.
the tool and and say we use it and they don't say anything more than that, we can do a lot better than that. Can we like treat this like we treat medical studies? I don't think so.
Yeah. Right.
Like if you give me $1 billion, maybe, right?
Yeah.
Like,
Well, I mean, I was sort of wondering, as that goes like into like making arguments for funding research in that sort of area, right? It's like, well, where's the data to show this is worthwhile?
But I think transfer is an important question that you were talking about, and I think you can do that by essentially like. Seeing how well people do on exam questions on that or on paper,
Yeah,
in semesters where they didn't have this versus when they did, and I would like to see more of that.
yeah,
It's also, I mean, you could do more log usage analysis if you like kept track of how people interacted with this and then try to like notice when people were getting stuck or like in principle, you could notice when people are clicking by seeing that in a log.
yeah, right.
Requires some sophisticated data analysis jobs to like take event logs and analyze like patterns within. Gotta go take a class about that. Right? You should do more of that. I haven't seen anyone try to do that. Partly the problem is with coding kinds of tools like Hawk, you get too many states that don't make any sense. Like first figure out. Yeah, we thought you could probably do that. Or you could do it.
You just work it out every time they
Every time it's like.
submit something change.
Yeah. Very good for this.
Yeah, because there were like like. I don't know, there's at least 10 papers where someone has tried using cock in their course, or like
Yeah.
there's hundreds of these kind of people have designed interfaces for things. But the reason why the paper that made it into talk was because they had actually gone in and like a lot of these papers you can read it and go, oh, that's a cool idea.
Yeah,
But if they actually like do just any sort of user study, and it doesn't even have to be that good, but then they can go, oh, we learned, this is actually important bit, and then you can see, oh wait, actually scaffolding is actually a very important question. Oh, actually, like yeah.
do you happen to see any for I know there's folks who are trying to use like in math lib in like a figure out education.
I wish someone had written something. You'll see on this paper, on this he cites Buzzard there,
Yeah, right.
but all you can do to cite Buzzard is cite his WordPress blog. Like that's it.
Yeah,
Like I don't know. He talks. He has papers.
Specific blog posts that just like the top level of the blog.
Right.
right.
He has papers that talk about like specific difficult proofs. He did in Leeds,
Right.
but he hasn't actually written that.
Category called formal mathematics course.
It's
The course called one.
right.
But I know people like his organ. Cause he's such like a.
Yeah, there's so many people working on
such a
this.
zealot for this.
I wish there were. Yeah, I personally couldn't find any paper, but there might be some.
Click on liquid tensor experiment. I believe that's the tool that they're using for education.
Liquid tensor experiment.
Yeah. I don't even know that reference.
It's now fully completed.
It's an old math rock band called the Liquid Tension Experiment.
Interesting.
Maybe in this blog post we have. Maybe this is what you cite.
Yeah. Amazing developments. That would passing the title at a CSN conference.
Yeah, it's like he's just asking what's the significance of theorem 9.4. He's not. He's doing some very cool work, but I haven't
Yeah.
seen anything written up.
Well, click that original, that first link that says liquid tensor experiment.
This was the Fields
One
memo.
challenge to formalize this thing out.
Yeah.
Yeah.
All right, I'm not teaching freshman at CS back in that's debating groups.
I think he is doing something on undergrad students, right? Corporate.
Yeah, yes, and there's a
I think Jeremy Evergard and Robert. All shortlists. Oh, this is what I was thinking.
yeah, there's the note for number game.
That's like great.
Cool. The new version. Very cool.
Oh, wow, pretty. Wait, this week.
Oh, we got German if we would like it.
Sorry, over.
There's a set theory game.
No,
But yeah.
yeah. Tutorial world. Yeah.
I don't know if they've got a paper there. Maybe.
Early world. Oh wait, actually, what was that? It's a logic game. Yeah. Good logic. Yeah, almost that.
Constructed logic.
Yeah, let's be curious about the tactics on the right. Included evidence that he got by. What?
What?
See
Exhibit evidence that you were working on Hazel.
I mean,
exactly, it's in the notes, so you
just press exact. Man,
your
let's-
goal is P, your assumption that you do is P.
Oh,
Oh.
there's something here.
There's the button there, yeah.
So if we just press exact.
Yeah, that's what it wants. Oh, we gotta say
Is that a profiles?
back to-do list.
Oh.
To-do list. That. Yeah, this is just not cog. Yeah.
No, cut. Okay.
Well, yeah, I guess that sort of gave you like a list of tactics which you unlocked or not unlocked. Yeah, so it's sort of like a progression. This dance going up.
Yeah, I mean, it means it's not overwhelming at the start, right?
Yeah.
Yeah.
Like they said it was like a fun with the footer of that page starting on the game. It said it was funded under like anticipating. Yeah, what's that funding?
Ugh.
German funding source. Oh.
Yeah.
We're gonna fund this.
Using your push out. Any edition.
A lot going on. I mean,
Yeah.
Yeah. There's a lot going on, but there's always like I know they just finished finance last year a few weeks ago,
Oh, yeah.
and I just remember seeing Larry Paulson just replied like, "We've got this in Isabel. We've had it in Isabel for years. Have you not been excited yet?"
yeah, no, fish is better than email. Chanel's got by far the most interesting one, $7.
Yeah. Hmm. Hmm. Any sense on where, like, I guess as you're looking through it, it seemed like there was a lot of activity in like the or late 1990s, early 2000s, and maybe a dip or something? Because you have like a lot of examples from
Oh,
that sort of thing here. I didn't know if
yeah, I think that possibly was a dip. I don't know whether it was just like in the 90s they were just saying, "Is it possible?" Right?
hmm,
And eventually, by the early 2000s, we worked out, yes.
yeah.
There's also some connection probably to the artificial intelligence excitement. Like in the 90s, AI meant prologue and proof and first order logic, and so they were probably thinking a bit about that, and then got forgotten that. Yeah, and it's a general problem in programming language interface stuff is that someone in the 90s has already come up with your idea, but they didn't run a user study on it.
They badly implemented in the future study.
Yeah.
So
Interesting.
Cool. Okay.